Okay, here we go. Section 3.5. Believe it or not, we're at the end of chapter 3 already. You'll notice a pattern in this book. We learn how to do stuff, and then in the last section of every chapter, we set it to word problems, which is really should be our ultimate goal to be able to apply these things. So we're going to apply linear functions to word problems. And these, like I mentioned in class, these aren't the most exciting word problems because anything that grows at a steady rate, there's nothing real exciting happens. Just in this example, you're putting the same amount of money in the bank every time. At one point, someday we'll talk about earning interest and interesting money problems. But right now, you're just depositing the same amount every time. So there are two setups that you need to be able to deal with. This is the most common in our book, is where the context of the situation gives you two data points. So in this case, you take some money and you open a savings account. I'm not telling you yet how much money you deposited on your first trip to the bank, but I'm telling you 7 months later you have $378, and 4 months after that you have $546. So what you do is from that sentence you get two data points, and my two data points are 7, 378, and 11, 546. Okay, in this case, x is time and y is money. Anytime you have time as one of your variables, that's always going to be x, because x is the independent variable and y is the dependent variable, and time doesn't depend on anything. No matter what else is going on, time is still ticking away. So these are the 2 points that I need to turn into the equation of a line. Again, with my technical difficulties, I'm doing this without writing on the smartboard. So I think what I'll do is pause, write it, and come back and talk. So pause and unpause. So let's see. From those 2 points, I first calculated the slope, which turned out to be 42. I did y minus y over x minus x. And it does not matter if you do 378 minus 546 over 7 minus 11. In that case, I'd get negative 168 over negative 4, which would turn out to be positive 42, as long as you're consistent in the direction. Okay, and we're talking about money here increasing, so this slope's going to be positive. From here, you can either go to point slope form and choose one of the points, or a lot of times people will use slope intercept form, plug in the point. In this case, I used 11 and 546, my slope of 42, to solve for b. It does not matter which point you choose. Either way, you're going to get 84 for your intercept. All right, so next question. All right, b is my favorite question out of these four because its context is what our goal should be. So what does slope and y-intercept mean in context? And there's not really a formula for finding this out. It's just y-intercept would be what would happen when x is 0. And when x is 0, that means time is 0. And time is how much time since you opened your account. So when time is 0, that y-intercept of 84 means that 84 is how many dollars you took to the bank on that first day. So $84 that you deposited on day 1, or on your birthday, that's the context of our y-intercept. And the slope equals 42 means you deposit $42 each month. Okay, so all linear functions, they're going to have a starting point and a rate of change. How much y is changing with each increase in 1 unit on the x-axis. Okay, so I like that particular question. You're always going to have questions like C and D on this style of problem. And basically, once you get your function, and our function is over here, I'm going to basically ask you for a y if I give you an x, and I'm going to ask you for an x if I give you a y. So part C, how much should you have 2 years after you open the account? One small hang up, this is 2 years. and x is measured in months, so be sure you use 24 months. I'm going to pause, fill this in, and be right back. Okay, so if you plug in 24 for x, which is 2 years measured in months, you just multiply it by the 42 and add the 84, and you end up with $1,092. Like I said, there's nothing real fancy about this. I mean, you can't get a raise and deposit more money. You can't do interest. Nothing ever changes in linear functions, which makes them kind of weak as far as making up a word problem, but important nonetheless. Okay, so what happens is usually they ask you for a y based on a given x, and then they'll ask you for an x based on a given y. So in this case, I know my equation. I know I'm looking to buy a $5,000 motorcycle. So how long is it going to take me? Y is what's given. I need $5,000, and x is what I'm looking for, how long that's going to take. So pause. And here's the solution to part D. If you need to raise $5,000 in an account where you're putting in $42 a month, and you had $84 to start, Y becomes 5,000 and X becomes my unknown. So 2 steps here, minus 84 from both sides, and then divide by 42, and you get a little bit over 117 months. So after 117 months, you won't quite have it, and on that 118th month, you will have it. So that's roughly 10 years, which tells me either you need find a cheaper motorcycle or get a better job and start putting more than $42 a month into your account. But just to review quickly, this is one of the main styles of linear problems. You gather the data from the question, which is 2 data points within your question. 7 months, you have $378 in 11 months total, which was 4 months after that, you have 546. So we turn those into data points, find the equation by first finding the slope. The context of the slope and intercept, my main thing is this right here. If you don't know what those mean, then really why make a word problem? And C and D, given an x, predict a y, and given a y, predict an x. So that's the majority of this section. Just for your info, we're not going to test after 3. We're going to wait and do it after 4 as well. So remember to be working on your Chapter 1 and 2 test redos to get some of those bonus points. And I will see you in class tomorrow. Young out.